Hello and welcome back to this course on OpenCV for secret agents. In the previous section, we helped Benji detect objects. In this section, we are going to build a face detector so Benji can detect the enemy's faces. We're going to first understand what face detection is and then look at some common techniques and finally build a face detector using a pre-trained model. Why do we need face detection? Face detection is the first step towards face recognition, and we all know how popular face recognition is these days. From unlocking your phone to real-time surveillance, face recognition is used everywhere. And if we look closely, face detection is a twofold problem. The first step is classification. Is there a face in this image? And the next, if there is a face, where exactly is the face in the picture? And that's a localization problem. Both these combined forms a face detector. There are many approaches for face detection. One of the earliest is the knowledge-based method. In this method, a set of rules were devised and it is heavily dependent on human knowledge of faces. For example, the rules could be checking for the presence of nose, eyes, etc., or maybe the distance between the two eyes. So the biggest problem people faced with this method was coming up with the rules. If the rules were too generic, it wouldn't detect many faces, and if it became too specific, it couldn't detect a variety of faces. Because there is so much variation in the faces. It differs from one person to another, it differs from the race, the country of origin, etc. So you couldn't make your rules too specific just to detect one kind of faces, and you couldn't make it way too generic that it wouldn't detect at all. So they had a lot of problem coming up with the rules. And to overcome some of these problems, they came up with this feature-based methods. These methods rely on structural features of the face for detection, but they had their own problems. The structural features that we were trying to extract were subject to changes based on illumination, occlusion, etc. The faces would look different in different lighting conditions, or it would be very difficult to extract features if, say, there were sunglasses which would cover their eyes, so you couldn't detect the presence of eyes at all. Then the next one in the list is template matching. In this method, standard patterns of face or features are stored and then the input image is compared with this template. The biggest problem this faced was the variation in poses and expressions. And if you had to, say, train for each pose, each variation, each expression, then your training would just go on and on. It would just explode because there are so many possibilities. And it became very difficult to generalize against all pose and expression variations in case of template matching. And so this paved way for what's known as the appearance-based matching, appearance-based methods, which rely on statistical and machine learning techniques to learn similarities between faces and the differences between a face and a background from a number of example images. Now, under appearance-based, there are a number of techniques that can be used. Some of it are like eigen-based methods. They rely on the eigenvalues and principal component analysis to detect faces. The other one is the support vector machine-based techniques. Support vector machines are linear classifiers where the separating hyperplane is chosen to minimize the expected classification error. It's a lot of math, but mostly a linear classifier that will be used in with other feature extractors. We could also train neural network that's becoming most popular these days. We'll be using this technique to build our face detection model. But otherwise, we could also train hidden Markov model for pattern recognition. Particularly, we'll be using a single shot detector with residual networks.